Next is paragraph type questions. So let us solve this question number 51 and 52. It says that consider a function fx equal to sine inverse 1 minus 2 times root x plus cos inverse 2 times root of root x minus x plus tan inverse root 2 minus 1 minus root x divided by 1 plus root 2x minus root x. So we have to answer the following questions. Let's firstly rewrite the function fx. See, fx is equal to, now it can be seen that sine inverse 1 minus 2 root x can be converted into cos inverse of this thing, right? If we form a right angle triangle, taking this angle, and let's take this 1 minus 2 root x and this is 1. So this will be, when you solve it, this will be 2 times under root of root x minus x, right? So this value can be written as cos inverse of 2 times root of root x minus x. So we will get 2 times, so it is equal to 2 times cos inverse 2 times under root of root x minus x. But it should be taken care that this will be the case when 1 minus 2 root x is greater than equal to 0, right? 1 minus 2 root x greater than equal to 0, which means that x will belong from 0 to 1 by 4, because domain of the function is 0 to 1, right? Domain is 0 to 1. So when x goes from 0 to 1 by 4, only then 2 times cos inverse of this thing will be obtained, and in the other cases it will be minus of cos inverse of this thing. So these two terms will get cancelled, right? Now further, let's talk about tan inverse. This is very easy to see that it can be written as tan inverse root 2 minus 1 minus of tan inverse root x, because it is the formula of tan inverse a minus b upon 1 plus ab. So this will be the case when x belongs from 0 to 1 by 4. Also, we can write here the value of tan inverse root 2 minus 1, that is pi by 8. Now let's talk about the other case, that is when x goes from 1 by 4 up till 1. For that case, the value of fx, these first two terms will get cancelled. So we will be left with pi by 8 minus tan inverse root x, right? So this is our function fx. Now domain we have already found out, we have to find the range of this function. So it can be observed here that minus of tan inverse root x, it will be a decreasing function. Also cos inverse theta is also a decreasing function, so we can say that this function is decreasing. Also, let's talk about the another one, minus tan inverse root x, again decreasing function. So this is also a decreasing function, which means that fx on whole is a decreasing function. So to find its range, the range will be from f of 1 up till f of 0 closed. So we just have to find the value of f of 1 and f of 0 here. Now f of 1 will be equal to pi by 8 minus tan inverse of 1, that is pi by 4. So the value will be equal to minus pi by 8. Now f of 0, that will be equal to 2 times cos inverse 0, that is pi plus pi by 8 minus 0, that is equal to 9 pi by 8. So the range of the function is from minus pi by 8 up till 9 pi by 8, which means that from the given options, option number C is the correct choice. Now further in question number 52, firstly let's find the value of f of 1 by 3, which from this function can be written equal to pi by 8 minus tan inverse root x, that is tan inverse 1 by root 3. So this is equal to pi by 8 minus pi by 6. So that will be equal to minus pi by 24. Now it is asking the interval in which cot inverse minus pi by 24 is lying. So let's make the graph of this function. cot inverse theta is of this form, where this is 0 comma pi by 2. So at minus pi by 24, the value will be lying between pi by 2 to pi, because this is pi, right? So option number D will be the correct choice. That is, cot inverse theta will be lying between pi by 2 to pi. Now next is the paragraph for question number 53 and 54. Here it has been given that f comma g are lying from R to R be two functions defined as f of x plus 1 is equal to fx minus 5 upon fx minus 3 for all x belonging to R, and g of 2x plus 3 plus g of 2x plus 7 is equal to 2. So we have to answer the following questions. Basically, we have to find the fundamental period of fx and gx. Right. F of x plus 1 has been given to us. Let us replace x by x plus 1. So we will get x plus 2 equal to f of x plus 1, that is fx minus 5 divided by fx minus 3 minus 5 divided by f of x plus 1, that can again be written as fx minus 5 divided by fx minus 3 minus 3. So this will be equal to multiplying in the numerator and denominator by fx minus 3. So we will get minus 4 fx plus 15 minus 5, that is plus 10, divided by 1 minus 3, that is minus 2 times fx plus 9 minus 5, that is plus 4. So that will be equal to 2 times fx minus 5 divided by fx minus 2. So this is the value of f of x plus 2. Now, also from this condition, let us find fx. So we are given f of x plus 1 multiplied with fx minus 3 times f of x plus 1 is equal to fx minus 5. So we can say fx is equal to 3 times f of x plus 1 minus 5 divided by f of x plus 1 minus 1. Now here, replacing x by x minus 1, we will get 3 times fx minus 5 divided by fx minus 1, right? Now in this equation, let's replace x by x minus 2. So we will get f of x minus 2. So this is equal to 3 times f of x minus 1 minus 5 divided by f of x minus 1 minus 1. So let's put value of f of x minus 1 from here in this. So it will be equal to 3 times 3fx minus 5 divided by fx minus 1 minus 5 divided by 3 times fx minus 5 divided by fx minus 1 minus 1, right? So this value will be equal to multiplying in the numerator and denominator by fx minus 1. So we will get 9 minus 5, that is 4fx minus 15 plus 5, that is minus 10, divided by 3 minus 1, that is 2fx minus 5 plus 1, that is minus 4. So this is equal to 2 times fx minus 5 divided by fx minus 2. So it can be observed from equation 1 and 2. It can be observed that value of f of x plus 2 is equal to f of x minus 2, which means that fundamental period of fx is 4, right? So the value of t1 is equal to 4. Now further, let's talk about gx. So it has been given that g of 2x plus 3 plus g of 2x plus 7 is given to be equal to 2. Now if we here replace x by x plus 2. So we will get G of 2x plus 7 plus G of 2x plus 11 is equal to 2. So if we subtract these two equations, so we will get G of 2x plus 3 is equal to G of 2x plus 11. So we can say that the fundamental period of Gx will be 11 minus 3 multiplied with 2, that is 16. So we can say that T2 is equal to 16. So we have to find the value of 8 into 4, that is 32 minus 16. So it is equal to 16. So answer will be option number B. Next is question number 54, which says that if f of 1 is 6 and g of 1 is 7, then we have to find the value of this part, right? So we know that fx has fundamental period, that is t1 equal to 4, and gx have fundamental period, that is t2 equal to 16. So f of 1 have been given, so we can say that f of 1 will be equal to f of 1 plus 4, that is f of 5, and it will also be equal to f of 13. So all these values will be equal to 6. Similarly, g of 1 is equal to 7. So we can say that as the period is 16, g of 17 will also be equal to g of 33 will be equal to 7. So the question have become very simple. We just have to put the values here. We have 12 plus 14, that is equal to 26. So from the given options, option number A is the correct answer. So students, this was all about AIATS 1A paper 1. Let us now discuss paper number 2.